Hi, and welcome to the second video for the Ticket Out the Doors for Math 127, the content between Exam 1 and Exam 2. So the third day of Ticket Out the Doors that we had was February 27th. And again, it was our last configuration of our plane over the straight road, trying to determine height. So same idea, to determine the height of a mountain, angle of elevation from one point is 30 degrees, 1,000 feet closer, angle of elevation is 60 degrees, how tall is the mountain? So it's exactly like the first two videos we had here, it's just the algebra is going to be a little different, but the setup of the problem is the same, the methodology is still the same. Let's draw our picture so we can see what's happening. So we're at a point out here, angle of elevation is 30 degrees, 1,000 feet closer, angle of elevation is 60, y and x looking for the height. So now we have what? X minus y is 1,000. So for x, tangent of 30 is opposite over adjacent, h over x. So tangent over 30 is root 3 over 3. So cross multiply, we get x times square root of 3 is 3h. Divide everything by root 3. We get x is equal to 3h over root 3. For the y variable, we have tangent of 60 is h over y. So square root of 3 is h over y. Multiply both sides by y. Y is equal to square root of 3 is equal to h. Y times square root of 3 is equal to h. Divide everything by root 3. You get y is equal to h over root 3. So plug these in. We have x, which is 3h over root 3, minus y, which is h over root 3, is equal to 1,000. So again, to make the algebra nice on us, let's multiply everything by square root of 3. So from these guys it cancels, we get 3h minus square root of 3 cancels again, h equals 1,000 times square root of 3. So usually what do? We factor out an h at this point, but we don't have to do that. Why? Well, it's just 3h minus h. 3 minus 1 is 2, so just 2h is equal to 1,000 root 3. Divide both sides by 2, tells me that h is 1,000 root 3 divided by 2. Simplify, you get h is equal to 500 times square root of 3. So that is your first question. Second one. And so that's actually been all three varieties, right? We had 30-45, we had 45-60, and now we had 30-60. So you should be able to do the different variations. The key is don't just write them all down on your cheat sheet and give me an answer. I'll need to see the work. So you still need to know what you're doing, but you've seen the three different varieties, so you should be able to do all of them. Number 2 is our law of cosine problem again. We have in triangle ABC, side A is 6, side B is 5, side C is 7, find cosine of B. So cosine of B means that the side B has to be on the left, so B squared is A squared plus C squared minus 2AC cosine of B. So put in our values, B is 5, so 5 squared. A is 6, 6 squared. C is 7, 7 squared. Minus 2 times A times C cosine B. So 25 is 36 plus 49 minus 7 times 6 is 42, times 2 is 84. This guy here is 42 times 2, 84, cosine of b. Add these two together, you get what, 85? You have 85 minus 84 cosine of b is all equal to 25. And again, I will stress to you, 84 belongs to cosine of b. 85, can't subtract that. 85 minus 84 is 1. Oh, it's just cosine of b is 25. That's not how it works. This is attached, so I need to subtract 85 from both sides. I get negative 60 is negative 84 cosine of b. Divide everything by negative 84. So negative over negative is positive. Both of these have factors of 12, so 60 divided by 12 is 5. 84 divided by 12 is 7. So therefore, cosine of b is positive 5/7. So that's our answer to number 2. Number 3. Again, these are all for February 27th. Problem number 3 is our boat problem. We have 2 boats leaving a port at the same time. 2 boats. So the first boat travels north 60 degrees east at 10 miles per hour. Second boat north 60 degrees west at 6 miles per hour. How far apart in 1 hour? So, concept question time again. A boat problem, it's bearing and heading. What method are we going to use to solve this? We're always going to use law of cosines. Okay, fine. Law of cosines. Next issue, next concept. I'm given a heading. I'm given a degree measurement. That degree is always going to touch which axis? And the answer is the y-axis. So if I draw this picture and I don't have a 60 touching the y-axis on 2 different spots, I've drawn the picture wrong. So let's draw our picture. So the first boat, north 60 degrees east, so northeast is into quadrant 1. 60 degrees has to touch the y-axis, so the 60 goes here. And it's 10 miles per hour. The second boat, northwest, that's quadrant 2, 60 degrees, so headed this way. Again, the 60 has to touch the y-axis. And that's a speed of 6. This is only going 1 hour. So then we're looking for how far apart are these guys. So law of cosine, so we have what? X squared is one side, 10 squared, plus the other, 6 squared, minus 2 times these numbers, 6 times 10, cosine of the angle between them. So then, what is the total angle between these two? Well, it's 60 plus 60, so 120. So 120 is what goes in my formula here. So cosine of 120 is what? 120 is in quadrant 2. It's going to have to be negative. Cosine of 120 is negative 1/2. So if I simplify this, I have x squared is 100 plus 36. Negative times negative, so I'm going to be adding something here. 2 times 1/2, so those cancel out. So I just have 6 times 10, which is 60. So x squared is 100 plus 36, that's 136 plus 60 is 196. Now if you weren't writing this x squared the whole time, and you get an answer of 196, does that make any sense? One boat went 10, the other went 6. There's no way these things can be 196 miles apart. So we have to do what? Take the square root, so x is equal to the square root of 196. And if you want to leave your answer there, that's fine. It actually works out to a perfect square. I believe it's 14. But don't worry about that. If you get to that point, that's good enough. I'll accept that as the answer. So that was the third problem that we had on that day. That was the last problem that we had. So the next date covered on this video is March 3rd. So the first problem says find the exact value. And we have cosine of 78, cosine of 18, plus sine of 78, cosine of 18. So you're thinking, this freaking guy, he tells us no calculators, how am I supposed to figure this out? Well, how are you going to figure this out? And the answer is your sum and difference formulas. Which of our sum and difference formula has the form cosine cosine plus sine sine? Well, it's our cosine. It's cosine of s and t, and cosine has an O, which is opposite. O associates with opposite. So because I have a plus in this formula, it's going to be minus when I compact it down. So my s is what? S is 78, t is 18. So this whole piece here is really saying what's cosine of 78 minus 18. So this is what? Cosine 78 minus 18 is 60. What is cosine of 60 degrees? 1/2. So your answer to this is just 1/2. So look for that pattern. Is it a sum of sines? Is it a difference of sines? Is it a sum of cosine, difference of cosine, etc.? Second problem on this date. So we want to write as an expression, concept question. When you are, I don't even have to write the rest of the problem right now. If I write as an expression, should be screaming in your head what? Build a triangle. In this case, we're going to have to do 2 triangles, but write as an expression, and then we have in x and y. The fact that it says write as an expression should tell you build a triangle for this problem. So we have what? Sine of cosine inverse of x plus tangent inverse of y. So we're going to build a triangle. Method is the same. In this case, we have to do 2 of them, but otherwise everything else is the same. So I'm going to say that this inside piece that has the inverse function, that's my theta. So I get theta is equal to cosine inverse of x. So if I take cosine of both sides, I get cosine of theta is x. I'm going to call it x over 1. When I build this triangle, cosine is adjacent over hypotenuse. So by Pythagorean theorem, and again, I kind of mentioned it in class the one day, thing to keep out for, if I'm looking for the legs, it's going to be a square root of a minus. If I'm trying to find the hypotenuse, it's a square root with a plus. That should always work out that way for you. So that's this triangle. Then do it again. Let's call this phi. And make sure you call them different variables. If you call them both theta, later on you're going to be looking for sine and cosine of theta, and you don't know which triangle to use. So call one theta and one phi, or one alpha and one beta, or whatever you want. Just don't call them theta and theta, or x and y. Choose other variables. So we get what? Phi is equal to tangent inverse of y. So tangent of phi is y over 1. Build this triangle. Tangent, opposite, over adjacent. I'm looking for the hypotenuse, so this is going to be the plus. Square root of 1 plus y squared. Now here comes the step. Hopefully I've said this so many times that you don't forget it anymore, because you're like, oh, this guy telling us don't forget it. I get it. Rewrite the original. I'm looking for sine of theta plus phi. Sine of theta plus phi, that's your sum or difference formula. In this case, sum because of the plus. This doesn't mean what sine of theta, and then add it to what sine of phi, and you're done. That's not what this is. We're not distributing sine. It's our sum or difference, which is what? Sine of theta, cosine of phi, plus sine of phi, times cosine of theta. Now go to the triangles. Sine of theta, opposite over hypotenuse, so square root of 1 minus x squared over 1. Cosine of phi, 1 over the radical part, plus sine of phi, y over the radical part, times cosine of theta, x over 1. If you have done this correctly, the product of the first two and the product of the second two have the same denominator. So this one becomes what? Square root of 1 minus x squared over square root of 1 plus y squared, plus multiply numerators, x times y over the denominator. And because they have the same denominator, I can combine them. So I get 1 plus y squared in the denominator, and the top is just square root of 1 minus x squared plus x times y. And at this point, please draw a box around your answer and move on. Do not try to rationalize this. Do not try to simplify this. When you have right as an expression in x and y with the two variables, you are going to get very messy answers. That's okay. Don't try to make this thing look any nicer, because it's just going to be a nightmare for you. All right, and the last problem we had on this date was one of our simplified problems. And again, I'll remind you, math people were lazy. We don't write proofs as we're sitting around at night. We go to the book, we find them, we say, that one looks good, let me put that on the test. So if these give you trouble, my suggestion would be go to chapter 7.1 or section 7.1, try some of these, try them all. Try and do all the different proofs, and if you can get them, you should be fine with whatever's thrown your way on the test. So we have what? We have 1 plus cosine of x over 1 minus cosine of x minus 1 minus cosine of x over 1 plus cosine of x. So, concept question again. I mean, you guys have 20 of them, so there should be a lot. We have what? We have 3 different types, mainly, of our simplify or our proof problems. We have one term with all the pieces are not sine and cosine. So what do? We convert them all to sine and cosine and then simplify. We have one term with a sine or cosine sum or difference in the denominator. What do? We multiply by the conjugate. And third, we have 2 terms. What do? We combine it into one term. So what do we have here? We have 2 terms. So we're going to combine it into one term. And it's 2 fractions. It's one fraction minus another. So if you remember the shortcut for fractions, if I have a over b minus c over d, this is the same as a times d minus b times c over b times d. So we cross multiply and then multiply the denominators. So I get what? 1 plus cosine x times 1 plus cosine x minus 1 minus cosine x times 1 minus cosine x all over 1 minus cosine x times 1 plus cosine x. A lot of foiling here to do. Slow down. Be careful. Take your time. When we FOIL these first two, we're going to end up with 1 plus 2 cosine of x plus cosine squared of x minus, when I FOIL this one, I get 1 minus 2 cosine of x, negative times negative is plus cosine squared of x, all over. FOIL this guy, it's a difference of squares, so 1 times 1 is 1. The outside and the inside terms cancel, so negative times positive is negative. Cosine times cosine is cosine squared of x. So now, my suggestion, because of this minus sign, I would distribute it all to this guy. So we get what? Minus 1 plus 2 cosine of x minus cosine squared of x in the numerator. So simplify, well, we have 1 minus 1. Those two cancel out. 2 cosine plus 2 cosine is 4 cosine. And then cosine squared minus, oh no, I distributed, sorry. Cosine squared x minus cosine squared x, they cancel. So all I have left in the numerator is 1 minus cosine x. No, all I have in the numerator is 4 cosine of x. Sorry about that. In the denominator, I have 1 minus cosine squared x. I hope by this point in the semester, when you see 1 minus cosine squared or 1 minus sine squared, this is screaming at you, Holy Grail. This is one of them. 1 minus cosine squared is what? It is sine squared of x. So if you remember when I was telling you about these, you're always trying to look to either factor things to get things to cancel out, or do substitutions to get pieces to cancel out. At this point, what can we cancel out? Well, nothing. However, we can break it apart. The numerator is basically 4 times 1 times cosine. And the denominator is basically 1 times sine of x times sine of x. So if I look at these as 3 separate pieces, I get what? 4 over 1 is 4. 1 over sine is cosecant. Cosine over sine is cotangent. That's your final answer. So we simplified this guy into 4 cosecant of x, cotangent of x. And what did it take us? Basically 1, 2, 3, 4, 5. 5 steps. That's probably one of the longer ones that you'll have to deal with. If you find yourself 6, 7, 8, 9 steps on trying to simplify these, you probably have something wrong. Go back and check your math. All right, so that was 3-3. What do we got here on time? 23 minutes? Huh. Yes, yeah, because that was the second day, right? No. Okay, well, I'm going to stop that one there. We're at 23 minutes. So come on back. We'll look at another couple days. We'll take it out the doors on the next video.